this video we are going to be treating about Bayes' theorem in probability. Now, what is Bayes' theorem? Well, Bayes' theorem is a fundamental concept in probability theory that describes how to update the probability of a hypothesis based on new evidence. It allows us to calculate conditional probability when we know the reverse conditional probability and some other probabilities. Now, what that means is, for example, we are to find probability of an event given that another event has already occurred, or the probability of event A happening given that event B has already occurred. So we use the Bayes theorem to find these conditional probabilities. So you see that we were to find the probability of event A happening given that event B has occurred. Well, Bayes' theorem states that this is probability of event A and B happening by probability of event B happening. Same sense, probability of event B occurring now that A had already occurred is probability of A and B divided by probability of B occurring. So yeah, we can just we notice that we can compute that this multiplied by this multiplied by this is this multiplied by this is this. So we can just compute that this is equal to this. So we can also compute that this whichever you choose to make your subject to formula, depends on the kind of problem that you have. So yeah, we can just use our Bayes formula to compute any problem that we have. Now you might recall that probability of A and probability of B is from our previous probability that we did is now this is only valid for mutually exclusive events. Now, what are mutually exclusive events? Well, these are events that do not depend on one another, meaning that event A can happen without the occurrence of event B. Event A is not dependent on event B, and event B is not dependent on event A. For example, I want to find the probability of me eating rice today and probability of me eating spag later in the afternoon. Probability of me eating rice today does not affect probability of me eating spag later in the afternoon, they do not, occur at the same time, and they are not dependent on each other. So we can see they are mutually exclusive. Another example is probability of me, tossing a coin and rolling a die. The probability of me getting a head on the coin is not dependent on the probability of me, let's say, getting a 5 or a 6 on the die. So we can say that these events are mutually exclusive. Now, for events that are not mutually exclusive, the probability of A and B occurring from our base theorem is, in the same sense, so this is just taking this as a isolated formula from the base theorem. So these are for non-mutually exclusive events. So yeah, base theorem is mostly used for events that are not mutually exclusive. So with that being said, let's continue our journey. Now, from our base theorem, we can recall that from our base theorem we have this formula, and we want to find the probability of events happening given that event P has already happened. Pardon, this should be now. This should also be A. Now, in most questions, you won't be given the probability of B happening. Yeah, in most questions, they won't give you the probability of A B happening. Okay, so now how do we get the probability of B happening? Now we can from our laws of probability, so the probability of B happening is probability of probability of we given the area called A and B, or probability of not A and B. Remember, probability of A and B is same as probability of P and E. So probability of A and B is probability of B from your base theorem. Alright, and in the same sense, probability of P and not A. Remember, not A and B, B and not A are the same. Probability. So it's just B and A is the same thing as A and B. So yeah, we can just sub our values in where we have probability of B, A and B, or B. So we sub our values for these two, which is now O in probability means addition. So we have this here. So we can substitute this for probability of P. Alright. So we have recall from our base theorem. Now let's substitute our value for probability of P. Alright. We have so this is law of total probability in base theorem for the conditional probability of event A happening given that event P has already occurred. Now we can only use this, use the total conditional probability when is not directly given. It's not directly given, so we can only use the total probability of event P is not directly given. So now let's illustrate a problem of conditional probability with the base theorem. Now this problem says a specific component in an electric has a probability 1% probability of being defective. Probability of being defective is 1%. Now a quality control scanner is used to test this component before assembly. If a component is defective, the scanner correctly identifies as defective 95% of the time. So let's label this as true. So given that it is defective, the probability that it identifies it correctly or truly is 0.95. Right? Now, says if a component is functional, which is not defective, the scanner incorrectly flags it as defective 2% of the time. So incorrectly can be labeled as false. Alright, 2% of the time. So now it says If a randomly selected component is tested and the scanner flags it as defective, what is the probability that the component is actually defective? So now what we're really looking for is the probability that, given that the scanner flags it truly, what is the probability that it is defective? So this is what we have to find. Now from our base theorem, we know that probability of is from our base theorem over right. So we can just plug in our values and see, let A be probability that it is true, let B be defective. Alright, so we can see that right. Now we know that from what we did earlier should be plus it from what we did earlier, from the law of total probability. So we can just impute this into there. Alright, so to make it cleaner, let's just do it like this. Probability of now we can observe that this is same as this, but we were not given this to value. Alright, now we can, from the question earlier, we can actually find the values of this. Well, the probability of it not being defective is just 1 minus probability of it being defective, which is alright, and the probability of it being this, alright, it's just 1 minus it. So from here we can just impute our values. So we plug this into our calculator. Your answer is yeah. So just plug that into your calculator, and whatever you get is relative of. So that's all on Bayes' theorem, and hopefully we kick off in. We continue from where we stopped on this video. Thanks for watching. See you next time.